Okay, welcome back everyone. Today will be our last and final session on multiplayer workshop, and this will also be our last session for the semester. Yeah, uh, I think before we get started today, I'll just do a brief do a brief overview of what we will be doing today. So, we're going to be implementing a very simple lobby system so that people will be able to join and create rooms for this game. But we won't be going through how you can handle things like disconnection. I think we probably won't have enough time to do that. So we're only going to focusing on how you can use services provided by Unity to help you achieve very easy room creation and networking related stuff to connect your players together, even if they're across the globe, uh, to play your multiplayer game. So before we get started, uh, just very quickly, we're going to be using a third-party package to help us do to help us with the development today. And personally, I think this is one of the packages that uh, you should you should have in most of your projects, especially if your projects make it big. Okay, if your projects have very many code and you want to make it better, you probably will encounter some kind of computation that requires the use of things like coroutines or async await with C Sharp's task abstraction. But doing that has its downsides. Using Unity coroutine and using C Sharp's task has its downsides that may or may not make your that may make it less efficient. So there is this package called Unitask, which basically is a package that allows for uh, zero allocation async await in Unity. So when you are using a coroutine, or if you are using a C Sharp task, actually it allocates some memory on the heap. If you've taken 2106 before, you know heap allocation is pretty slow. So we try to avoid doing heap allocation as much as possible. Not only it is slow, it also generates garbage when when the object goes out of scope, that will require the garbage collector to suspend the whole program and try to clean up the memory so that we can recycle it. The problem with the garbage collector is that it will suspend all running scripts. This means that you may encounter micro stutterings in your game because the garbage collector is running. And we try to avoid these kinds of potential scenarios as much as possible, because having stutterings in your game is always a downside to your player experience. So when your game make it large and you have a lot of async await code, and as we all know, Unity's coroutine syntax is kind of disgusting to use in most cases, especially when you have to work with things like network requests. So the coroutine syntax can actually be pretty complicated or pretty verbose to use. So in this case, Unitask will help you solve most of this problem. Am I recording? Yes, I am. So Unitask, basically, as I mentioned, is a zero allocation async await library. It allows you to have zero allocation on the heap. It's not zero memory allocation, but all the asynchronous tasks that you create through Unitask will be allocated on the stack instead, which makes it more efficient, and there is no garbage that you need to clean up on your heap when where in contrast to using Unity's coroutine system and C Sharp's task system. It also has pretty good integration with the rest of the engine, so it's always good. Unity also came up with their new awaitable library package that you can use on Unity 6, but the same problem with the awaitable is that it also generates a small amount of garbage. So if you put it inside an update loop, it is still going to cause a lot of garbage, and it will still cause a lot of allocations, and in turn, it might actually slow down your game if you use a lot of it. So Unitas solves all of this issue. Okay, Unitas solves all of this issue, and it makes it much easier for you to work with asynchronous code. Big of a backstory is that this is a library created by Sci-Sharp. It's a subsidiary of Cygames, the publisher for games like Uma Musume. Yeah, so they also create a lot of packages that you can use not only in Unity, you can use them in a lot of the C# .NET part side of things, and some of these libraries you can also use for Godot. So recently they released this Z-Link library that allows you to have zero allocation link, which I think is pretty neat, but I haven't had the time to look at it yet. So, and there's also R3, which is a reactive framework that allows you to handle callbacks for reactive interactions. You can handle callbacks for reactive interactions without needing to write like basics without. Okay, it's actually you can handle reactive interactions with functional type programming. So this means you don't need to check for every update. It's going to check the callback for you because you have constructed that particular callback. But again, this is pretty advanced stuff, and I don't. It's pretty advanced stuff, but if you're interested, you can take a look at it. They have a lot of the libraries available. So yeah, but I think Unitask is the easiest and probably the most useful library that you're going to use. So let's just get this started. First of all, we need to install Unitask. And very simply, you just need to copy this git HTTPS URL. Just click down code, local, and copy. And then you go back into Unity and you go to Package Manager. You can click on this plus and install package from git URL and click on install. So this is going to install this package for us. Oops, sorry. It's not that URL. I think there is a specific one. Okay, sorry, it should be this one because this one can also be used for .NET. So there is this particular plugin you need to install. So you scroll down to the very bottom and you should be able to see this git URL. So you install this and it's going to run the installation process. So again, it is down here. You scroll all the way bottom and then you will see this install via git URL, and it gives you this this URL that you can copy. So it's only going to take you like a minute or so to install this. And now that you have installed it, you would see Unitask inside of your package manager by Sci-Sharp Incorporate. So I'll give you all a very quick moment to install this while I open up the Visual Studio so that we can work on the code. I see. No, yeah. Okay, so now that we have installed the Unitask package, we can get started with working on the lobby system. So we are going to first start off with the UI part because the UI part is going to be the easiest. We're just going to create a new scene. so that we can set up things to create or join a lobby. So let us just click on create a new scene, and then we're just gonna call this the menu scene. So we're gonna open up the menu scene, and we're just gonna set up some pretty simple UI for this. We're gonna set up two buttons first. So the first button would be join lobby. Okay. The first button would be join lobby. And let me just set this to scale with screen size and give this a resolution. And then we try to make this larger. Something like 300, 100 should be okay. And we're also gonna move the position Y to something taller, maybe 80. No, this would be the create lobby. Let's rename this as create lobby. And let's duplicate this and make this join lobby. And then we're just gonna put this down to -80 so it looks nice. So here inside of the text, we're just gonna say create room. Okay, we're gonna put the text as create room, and let's put the text size up to something like 48. And then for the bottom one, we're just gonna do this join room. Okay, let's also put this to 48. So since we want to have the capability to join a room, we need some kind of room code. So the way how the services that we're gonna use is going to generate a 6-digit room code that you can type in to join a room when you create the room. So we're just going to very quickly also add a text box over here, a text input box, so that we can we will be able to you know, it's like the lobby code. So let's also just put this down to somewhere like here maybe, and then let's increase the width, let's increase the height. So let's just put this to like 50 instead. -180. You know, just scale the UI to how you like it to be. I'm just gonna do this very primitively, but we're going to increase the size of the whatever that's inside here. So let's just make this 25. Okay, maybe 28. Okay, 28 looks nice. So now we have a very primitive set of UI that allows us to create a room and join a room. And we're just going to hook this up to the Unity Gaming Services that provides us with all of this utility for free. But when your traffic increases, you need to pay per use. Just for demonstration purposes, we're just going to use this because it's much easier to set up, and it's pretty good for you to learn about how to start out without needing to write a single line of server code. So we're just going to go into our scripts, and we're going to create a new script, new model behavior script, and we're just going to call this the lobby manager. And we're going to open this up. So the lobby manager is going to take in two references to our button. So it's gonna take in two buttons. So we're gonna take in the button for create room button, and also the button for join room. So we have the references to these two buttons. And we're also going to have a reference to the input field. It's the TMP input field. So the TMP input field, which is going to be the room code input field. So we're just going to need these three things. And here we're going to create three methods that allows you to create room, join room, or you know, we're just gonna create two methods that allow you to create a room or join a room. So let's just make this a private void create room, and also the private void join room. So since we are actually going to require some kind of network request to actually either create or join a room, I mean, it sounds pretty intuitive. I need to connect to some server to know the room details information before I can create or join. So actually, we're just going to change the return type to a unit task. So as you do this as a unit task, you also need to make this asynchronous. So this is basically, now we have created two asynchronous methods that uses the unit task API, which is zero allocation async await, for both of my create room and join room methods. So before we look into how to implement this logic, we're just going to hook up to the button callbacks so that we can add the input, so that we can add the event listeners to them. So as I create room on click, okay, I will add a listener to create room, and here you can do a forget so that you don't actually want to get any kind of return value from create room, because the return value here is not important to us. We're gonna do the same thing here for the join room button. So we're gonna join room and forget about the return value. So it's as simple as that. So now that we have hooked up everything, it's time to write the logic for create room. And before we do that, you'll first have to go to your Unity Cloud, which is cloud.unity.com. Okay, and you need to make sure that your project is already listed inside Unity Cloud to use the Unity Gaming Services. If you haven't already hooked it up, you will be able to hook it up in Edit, Project Settings, and inside of Services, you can link your project to your Unity Cloud. So Unity Cloud actually provides you with a lot of services. It also provides you with things like version control, so you don't need to rely on Git. But it's not as intuitive to use as Git, because all the version control must be done within the engine, and sometimes it bugs out and crash. So usually you wouldn't use it. But the rest of the services that they provide you with is pretty impressive. So let's just take a look at what it gives you, so you have a sense of what you can do with it. So it gives you player authentication and player management. This is for you to create accounts for a game if you don't want to write your own account code and maintain your own database. You can use Unity Gaming Services to provide this utility for you. There are things like DevOps. You can do developer operations with Unity Cloud so that it can automatically do version control and build automation whenever you push a new version onto your trunk. There are things like analytics and push notifications for your players. If you want to send them custom push notifications that is not from the app itself, you can also do that. There are things like cloud content management that allows your players to do user-generated content. If you play games like Animal Crossing, you know that you can create your own maps and stuff like that. So this allows you to store them without needing to, again, care about any kind of server-side code, because it's already all delegated for you. You just need to hook into the correct API to do so. Crash reporting. This is one of the more used features here, services here, especially when you actually deploy your game to production ready as production ready code. When you deploy it, you send it out to your player. Sometimes they crash and they don't know why, and then they will give you a bad review on Steam. So you kind of want to fix those kinds of problems, and the cloud diagnostic here on crash reporting will collect all the telemetry data that is going to be essential for you to debug why your game crashed on your player's machine, and you can try to take a look on how to fix it. So multiplayer, there are lots of things. There are distributed authority, which again, as I mentioned, I won't be going through because it's quite complicated topic. Multiplayer hosting, which basically allows you to host multiplayer games if you have your own server-side code, so you can deploy it directly without needing to find your own VPS to host it on, or to think about how to set up your AWS such that you can host your games on it. So specifically today, we're only going to be looking at lobby and relay, which allows you to create lobbies, and relay is a sort of service that allows you to route your peer-to-peer connection through their serverless infrastructure so that your player's IP don't get leaked. And it can also bypass certain network configurations that doesn't allow for peer-to-peer networking. For example, in NUS Wi-Fi, you can't do peer-to-peer. So relay allows you to use peer-to-peer even on a restricted network configuration. So things like economy and in-app purchases, I think this is pretty straightforward. Basically, you can try to monetize your games with your own in-app purchases, and this will handle all the payment services for you. Obviously, they'll take some platform fees, but it's probably sometimes it's better to figure out how to incorporate the payment service into your service if you just want to make it in-game. There are things like friends and leaderboard for you to do community. Again, you don't have to touch server-side code. It's just pretty simple service. Most importantly, you can put ads into your game through all of this Unity ads thingy. If you're making a mobile game, or if you've played some kind of idle mobile game before, you know how important ads is when it comes to their income. So yeah, you can put ads in your game if you feel like it. Unity actually bought ironSource, which is a pretty popular ad service for mobile games before this. Now they bought it, and then it's part of their service now. So there are also things like asset management and Parsec. Parsec is actually a remote desktop tool. You can download it for free, I think, but essentially it's a remote desktop tool. And things like there are new AI stuff like Sentis and Muse. Sentis is their large language model, and Muse is their 3D content generation model. And there's also communication. You can do voice chats directly with these APIs. But again, not important. You can take a look at those if it actually makes sense to your own project. But today we're only going to be looking at lobby and relay. So if you click on it, you can click on launch or learn more, and it's going to bring you to these web pages that tells you how to install how to link the Unity project and install the stuff. Okay, and also the documentations that you can do. So I'm just gonna click on the documentation as well, so that we can try to refer to it as we're going on. So yeah, I think we can get started with this. So first of all, we are actually also going to need to install the... Has this already been installed? I think there is the multiplayer, like the services package. Unity registry, services. It's part of multiplayer services package. So yeah, you need to install the multiplayer services package by Unity in the package manager to make use of these Unity services that I just mentioned just now, specifically for the multiplayer services. So again, this is going to take a while to do so. Wait. Okay. And now that it's installed, we will be able to start using the services inside of our code. So we're gonna start with create room first, because obviously without a room, how am I supposed to join it? So we're just gonna create the room. So let's start with pretty simple. We're gonna have to start with creating a room from the lobby service. So there is this it's like, take a look. You can using Unity dot. Where is the service for multiplayer? Multiplayer dot. No, I think my Visual Studio is not updated. Let me relaunch it. There's a package that you can use. Lobby data. Which package was this in? Okay, so in my lobby manager, I think it's called lobby service, no? Sorry, let me take a look. There is a particular namespace that I need to take. Where is it? Yeah, it's lobby service, but I can't find the can't find the namespace. Okay, so here it is. So unity.services.lobbies, and we're also going to do unity.services.relay. So these are the two services that we're going to use here. So we're just going to create a new lobby, create lobby async. Okay, we're just going to create a new lobby. So this lobby allows us to add a lobby name and also add a max player. So let's also just so we probably don't want to think about the lobby name because we only want to be able to join by code. So we are also going to, since we're also using relay, we also need to create an allocation with relay. So we're just gonna use the relay code as the name for this lobby. So we're just gonna do a relay service dot instance dot create allocation async. So as I create allocation, I will be able to get 2, which sets the max number of connections that I can go into this, which is the max player count that I can connect to this relay service. So I'm gonna create this, and then I'm gonna assign this to the allocation variable, and by awaiting this, I will be able to get this allocation. So I'm also going to do a allocation dot key. Oh, sorry, not dot key. There should be a allocation. Was it ID? No, that's the geo ID. Sorry, I need to look up the reference. Haven't used this in quite a while, so allocation, yes. There should be an allocation data that is inside of my allocation. Sorry. Okay, I created the allocation, so now I need to also get my... I think I need to join the allocation first. And what does this return me? An allocation created via a join code. Sorry, give me a moment. Okay, sorry, it took some time. So we first get the allocation, and then I'm going to get the relay ID from the relay service. So this is going, so we're going to get the get join code from the allocation ID, which is a dual ID. And once we get the join code, let's just call this the join code. So once we get the join code, I'll be able to use the join code directly as my lobby instance name. So I think this should return me a task of lobby. So I'm going to assign this to a lobby. Okay, gonna assign this to a lobby. But I also need to add a data to this so that I'll be able to propagate this relay code to the other players that is connecting. So there's two layers to this. As I join a room, as I create this relay allocation, the player actually needs to first connect to the relay allocation in order to join the room. So, but there is no, so the player won't actually know what the relay allocation is without knowing what the relay code is. So as I create the room, I need to propagate the data of this relay code so that players joining the session will be able to look up the relay code and find the relay allocation to connect to before they will be able to join the lobby. So it sounds a bit complicated, but it kind of makes sense because you want to wrap around the restrictions on a strict network stuff. So you first need to connect to the server before you can do peer-to-peer. It's essentially what that is. So here in my create lobby options, I'm just going to create a options new. Okay, so I can create a new that should allow me to add a data that should allow me to add this as a new data. So this data is actually just a dictionary of a string to a string to an object. So you can just basically put anything inside of it. Okay, so I create this dictionary, which here I'm just gonna call this a relay allocation. No, I'm just gonna call this the relay join code. And then let's just put this as join code. Is this not how I write this code? This? It should be equals. Oh, sorry. It's an entry in a dictionary, so it's like this. String to data object, so it's new data object, which is a new data object. What is a data object? Oh, I just put the value in here. Okay. Motherfucker, what is a data object? Visibility option, string value default. Okay, so I need to put the visibility option, which is going to be public. And the value is going to be a string, which is my join code. Very nice. So basically now I have propagated the join code into my lobby. So now every single time when someone queries this lobby, I will be able to retrieve this data to join the allocation and then join the lobby. Yeah, so it's quite trippy. Okay, it's quite trippy, but it is what it is.
It's recognizing it.
It isn't recognizing it.
Yeah. If you try to close reduce to the
Sometimes it doesn't work if you add the package manager. It's okay. Just take a quick rest as well.
Oh, there it is.
Yeah. It takes time.
Related changes involve Unity surface something. Wait, what?
Sorry, what?
Yeah, when copy them.
Oh, did you install the relay package when you removed that?
The relay.
Yeah, you need to remove that one because
Oh, okay. Oh, so that's why they.
It causes a conflict with the rest of the code. Okay, so let's try to continue from here. Now that I have the lobby, I need to. What do I do with the lobby again? Whatever. Okay, so now that I have the lobby, I now need to set the relay so that I tell my network manager that I'm currently using the relay service. Because if I don't do that, it's not going to know I use the relay service, so it doesn't connect to the relay server. So here I'm just going to do a network manager dot singleton dot I think it's set relay. No. Relay. Where is it? There's so many shits over here. Get component. Okay, get component unity transport dot set relay server data, and I'm going to set this to the allocation dot relay server. No, wait, what do I do this? Set relay server data, which takes in the this either takes in this or relay server data. So allocation dot I think you do this, no? You don't do this. And what I do? Oh, to relay server data. Okay. Okay, so I create this, I return the relay server data, and I'm going to use DTLS for the connection. Yeah, so now I'm connected to it. It's basically as simple as that now that I'm connected to it. So now that I'm connected to it, I need to also make myself the host. Because as I create the room, I am the host, right? As I create the room, I am the host. So I need to make myself the host as the host. Okay, as simple as that. So this is practically the code done. There are some other stuff that we can add later, but right now, this is all we need to do. So now, in my join room, I am going to do the same. Okay, but first I need to retrieve the room code, which is going to be my input field, the text inside my input field. This is what the player types in when they see the room code. So now that I get the room code, I first need to get the allocation from the relay service. No, I need to get the lobby from the lobby service first, which will be lobby service dot get dot instance dot get lobby async from the room code. So once I get the lobby, I need to get the join code from the lobby, the relay join code from the lobby, which is going to be the lobby dot data and then we get the key relay join code dot value. So this gives me a string, which is the join code. Now that we have the join code, we will be able to get the relay allocation from the join code. And I just need to join the allocation directly from the join code. So now that I joined the allocation, now that I joined the allocation, I also need to set, no, actually before I join the allocation, I need to get the allocation first. It's like there is a... Wait, is that all? Get join code async. No. Well, I think I just joined the allocation here, yeah. So I joined the allocation. Is that what I did? Yeah, correct. So I need to join the allocation first, and then I tell my Unity transport component that what my allocation ID is. So I do the same thing here and use the same connection on both sides, which is DTLS. And then now I do this as start client. So yeah, this is basically all the code you need to create a lobby and join a lobby. So let's also get ourselves some debug statements so that I will be able to see what lobby I'm joining. So let's just say room code, which is equals to lobby.id. So I think this gives me a string, yes. And let's also get myself this allocation join allocation relay join code, which is equals to join code. Forgot to put the string interpolation here. So now let's also add this here. So we're gonna say debug.log joining room lobby dot joining room code. Let's put this up here so that I can sort of see this in action. And then joining relay allocation with the allocation.i dot allocation dot instance dot get join code async allocation ID. A little bit here. Probably not a good idea to do this, but this is just for debug purposes. So yeah, let us try to set up our scene so that I will be able to make use of this. So we're gonna go into my sample scene first, and we're gonna take our network manager and put this into we're going to just take our network manager and then put this into our menu scene. Save, and then remove the network manager from my sample scene. So the network manager should always be in the first scene where you kind of want to have the network manager to be in, because if you don't have it, then it's not going to instantiate an instance. Yeah. now I should have practically everything working. Let's create an empty game object for my lobby manager. And let's just add a component to this, which is my lobby manager script. And let's hook up the buttons. So create lobby, join lobby, and input, which is lobby code input. Okay, so now I'm going to go into window and let us get my multiplayer play mode. Let's get our second player up again so that we can test out the code to see if we actually got this working. Yes.
Yeah,因为怎么他上面有些设计是在去然后对哦，这就是but I'm pretty sure I maybe oh there was something it was because of different
Maybe. Okay. So now that we have the second instance, we can just test this out and see if this works. We're gonna click on. So before we work on this, we should always go into our build profile and add this open scene and then drag it up. So sample menu scene first before sample scene. You should always do this because if you don't do this properly, you actually don't get your scene management to work properly on a network scenario. Okay, you need to go to build profiles and add open scene in your scene list. Open scene list and add the open scene and then move the menu scene up. Okay. So now as I click play, I will just click on create room. Here, I can click on it. That is weird. The event system is up. So it should have been able to. I should have been able to click on this. Blocking objects none. That is very weird. Yeah, that is very weird. Just try again. I think the event system might be balked. Let me just remove this. Just create a new image. It's very weird. I thought why is the event system not working? Is it because of that OnGUI? What if I disable the helper script over here? I don't think the OnGUI is supposed to. Yeah, I think the event system is just blocked. Okay, let's try to fix this. And first of all, just copy paste canvas. Let's remove this. Should be able to still paste it. Yes. The event system. Let's create a new image so that we re-add the event system. Remove the canvas and paste it down, and let's play again. Oh, object reference not set to an instance of object. Okay, now there's an error. MLLB manager, and then it's normal. Sorry, give me a moment. Let me try to fix this first. That is very weird. I still can't click on my button. Oh, I think it's because the multiplayer play mode is interfering with it. Okay, let's try again. I think it might be because the multiplayer play mode is interfering. No? Yeah, I can click on it there. Yeah, I think the multiplayer play mode may be interfering with the things around. So let me just. I think we'll have to restart the engine, the editor. It's just not a very good engine to use. Honestly, it's not stable. Hey, they say they're working on the stability. I don't know. It might be better next year. Now we should be able to see this work. No, still no. Nope. That is very damn weird. Let's just close the simulator tab. Maybe that is interfering with me. Yeah, now I can click on the button. What? What was it?
Like the error.
Yeah, okay, so the error is correct. That's because we forgot to initialize this. So we actually need to initialize our Unity service. As I start this out. So I am just going to make this an async void, and then let's just await this initialize async from Unity services. So if you don't do Unity services.initialize async, it's actually not going to initialize the service properly. So if you want to use any kind of Unity service, you must call the initialize async somewhere in your code.
No. Okay, this is good.
So let's just open up the multiplayer play mode again, and then we're just gonna take a look at this again. So let's get this turned on, and then can see that we're in the here, so let's click on play. And in theory now I should be able to create a room. You're not signed into the authentication service. Sorry, I think I need to authenticate somewhere. Okay, I need to somehow hook this on. Yes, so this should be here. So where am I? This one. So once I initialize, I also need to run the sign in. It's like authenticate anonymously. What the fuck was it called again? Yeah, sign in anonymously. It's authentication service dot instance dot sign in anonymously async. So I also need to sign in. So the thing here is that the lobby service and everything is actually tied to the authentication service and the Unity services. So it actually creates like a new player profile. If you don't have a player profile signed in for your player, then your player cannot access these services because Unity wants to take all of your data. So in order to authenticate without a player profile, you just do sign in anonymously, async. Then it signs it in. If you have your own sort of like player login system, then you just sign in here as you use the service. But in theory now I should be able to authenticate myself properly. So let me just go to my player tool and create the room. So click on create room, and now you can see that my relay join code is BFHDPW, and my room code, sorry, this is not my room code. Hang on a moment. It's not lobby.id. It's should be lobby.lobbycode. Yes. Okay, yeah, it should be lobby.lobbycode instead. So let's try again. I'm just gonna click on play, and then now as I click on create room, I will be able to see a 6-digit code, which is this room code that I'll be able to join. So here, if I go to my second player and I type this, why is my second player not playing? Unity, fix your shit. My second player is not playing. Okay, now this is playing. Okay, I create a room again. This is putting... What in the fuck, Unity? Fix your shit. Okay, I can type. Okay, the character is not showing. So now I do this, and I click on join room, and it tells me that the wet. Wet. It's lobby code, not ID.
Yeah, I teach you the lobby code. Oh,
I think I used the wrong API. I don't think it's join. So get lobby async. Yeah, I think I did this in the wrong order. It should be join lobby by code async. Yeah. Let's join lobby by code async as I do this lobby stuff. So yeah, I joined the lobby by code. I click on play now. Then I should be able to create a room. This gives me that. And then I can join the room here. LDH QQ8 join room. And then I join my allocation correctly. That is not correct. I don't think I joined the correct allocation. Did I join the correct allocation? Sorry. Let me just take a look. That is the relay code. I joined the allocation. Oh, because this is a joint allocation. Okay. Yeah, I don't need to do this because the joint allocation is a different allocation than the original allocation. So I just do this, yeah. Okay, so essentially now I practically joined. So now I just need to make sure that I actually transition to the new scene. So let me transition to the next scene, which is where I play my pawn. Singleton dot scene manager dot load scene sample scene, and the load scene mode is going to be select what load scene, and then I need to add the load scene mode as single. Okay. So what this does is that if you load a scene with the network manager's scene manager, with the network manager's scene manager, it will automatically sync the scene updates to your clients as well. So if you want to make sure that all the clients look at the same scene, which usually that is what you want to do, you would need to use the network manager's scene manager instead of the normal scene manager that you would use. So now, again, now I should be able to basically play Pong with the different people. So I'm going to just create a room. Just give me my player 2. My player 2 is not playing. What in the fuck?
Oh, not done. You? Yeah, like you two some of thing. Yeah, when I found I don't know what you.
I am just going to do this. It's like join room here. So as you can see, my player 1 actually don't have the paddle. So why is this the case? Okay, so the reason why my player 1 doesn't have the paddle is because remember how we spawn the paddle? We spawn the paddle when the network manager creates a connection. But because since that was on the second screen, I actually get the connection before I actually get the host connection before the network manager before I load into the second scene so that I can actually get to the network manager's callback. So the way how we can kind of fix this, okay, the way how we can kind of fix this is there are multiple ways to do this, but the easiest way to do this is I go into scenes, I go into sample scene. Okay, I go into sample scene. And essentially I just drag the player prefab in and then put this into the previous position that I want this to be, which I think is okay, no. I think I'm just going to update my spawn manager script to do this. So I'm just going to edit the spawn manager script, which in this case, on start, I'm not going to do anything. No, on start, I'm going to say if network manager.singleton.isServer. So if I am the host, I'm going to spawn the player position with the client ID of 0. So I just manually invoke this because I can't subscribe to this callback as the server yet. Essentially. Because the client connected callback gets called way before the scene has been loaded. So let's get back to our editor, and as I click play, sorry, it shouldn't play here. I should play inside of my menu scene. So I click play here in my menu scene, and then I create a room. Here I will be able to join the room. As you can see now, my player 1 also has this, and I can also create the room. I can also join the room. HKLC, I join the room, and I will be able to see my player 2 over here. So because my player 2 joined way earlier, there is some kind of score unsyncness over here. But I believe once I get to this score, I will be able to see this jump to 2 instead. Yeah, so then now that is synced properly. So yeah, basically now we have practically made a functional GUI. We just need to make sure that we put things like UI, which I'm not gonna go through how to do that, it's really trivial, to showcase your room ID and whatnot. But now I'm kind of want to fix the ball, so the ball only launches when both players are connected. Yes.
I'm getting an HTTPS setting and I'm trying to get my data to join the video. Yeah.
Did you change the code? Because I think I did something wrong just now as well. It should be join lobby by code async.
Oh, right.
Because the get lobby async actually expects like not the room code but room ID. So yeah, let's try to update the ball so that this only launches if I have the enough players. So I am going to hook up to a callback on client connected. On client connected, it's like, what is it called again? It's network manager dot singleton.onClient connected callback. So I'm going to just call this, handler. So this should take in a ulong, which is the client ID, like I did. So now when both players are connected, I'm just going to do a okay, sorry, this should be in else. So this callback is only subscribed on the server side. And then I'll say if client ID equals 1, so if the second player has joined, I just start the coroutine to launch my countdown. So since we also imported unitask, let's try to make everything unitask. I'm just going to replace my launch countdown coroutine with a unitask. So you can replace all coroutines with unitask and it will work properly. So here I'm just going to await unitask dot wait for seconds, the launch countdown. So this is 0 allocation. When you do new wait for seconds, it creates garbage as well. So instead of start coroutine, I am just going to do a launch countdown and then don't forget. Basically that is it. And then let's rename this from countdown coroutine to launch countdown task. So it looks proper. Now I also just need to do the same thing, launch countdown task, then send to player dot forget. So now this is fully async. We use unitask for this. You don't always need to use .forget. You can also assign this to a discarded variable, but it's not as good. Usually you just do .forget if you don't want the result from the unitask. Or you can do, I think there is a unitask dot something like execute or something. .run, yes. So you can also, no, actually, I don't remember what it is, but you should be able to create. Yeah, you should be able to. Yeah, I think you just do a .forget here. So yeah, essentially now I have all that I need to make sure that everything is working. So I'm just gonna click on play here to see that my ball is currently updated, to check that it is properly updated. I'm gonna create a room. This is going to give me a room. There's my room ID. It is WT6M77. The join room. And now that I joined, only then, 2 seconds later, the ball will shoot out. Then I can control the ball. So yeah, essentially now I have played. I have working Pong. Yay. Okay, so there are actually more stuff that you can do to kind of refine this, but I don't think I'll have enough time to go through all of them. So, but now that you know the basics of how you can do multiplayer, you should be able to figure out how to do these through the APIs and the documentations that is given by Unity. So, a couple of points. In fact, you should handle the case where the player disconnects from the game. So there is a callback from that. There's a callback for that. It's called the network manager.singleton. Okay. On client disconnected callback. So this has the same signature as the on client connected callback. It will tell you which client ID has disconnected from this game. So then you can handle the disconnection logic. For example, you want to reset everything, you want to put the ball back to the original or origin point, everything. So you will be able to do that with this on-client disconnect callback from Network Manager. I'll leave that to you. You can try to figure out what you want to do with it, with this knowledge. You can also do things such as taking in the player's name and then displaying the name in the game session. So that means you need to create a UI to take in the name, but most importantly, you need to sync the name across the games. So this can be done with the network variable that we have used last week. But because network variable, you actually must send a fixed size data with a network variable. It is how you sync data across the network. It must be of a fixed size. If the size is variable, you can't use the network variable to do it because it sort of breaks how things are being serialized and deserialized underneath the hood. So if you take a look at Unity's network variable documentation, okay, it shows you a list of data types that you can use for this network variable. You can use primitive types, which can be directly serialized. So you can use every primitive type except string, because string is technically variable length. So if you want to send string, you can use one of these fixed string data types that is provided by Unity. So it gives you a fixed size string. It's serialized properly as a fixed size string, and you can't have more than that. So if you want to send string over the network, it must be a fixed size string. There is no other way around this. And you can also see that you can define a struct type that implements the iNetwork serialized by you can define a data type that implements the iNetwork serializable interface. So what this does is that you can basically just makes it serializable, so you can send a packet of data with all the fields that you want directly, so that you don't need to send like 5 requests and sync 5 different variables. Instead, you sync one variable which contains all the data you need. I'm just gonna go through very quickly how you can sort of like implement this this struct. I'm just going to write this here just as a demonstration, but I am not going to include this in the GitHub repository. So say now I have the, okay, I'm just going to put this in the lobby manager. So say now I have the player data. I'm just going to define this as a struct because why not, right? So I define this player data, which implements the iNetwork serializable interface. So this interface requires me to implement this this method called network serialize, which takes in a T, where T is an iReader writer. Don't think about this too much, just follow this, right? So inside of this struct, I can define the data I want to store in this. So maybe I want to store an integer, which is like the player ID. Okay, maybe I want to store some float, like the player score, for example. Right, so you can define these. If you want to store a string, you must use the fixed size string. So there is a fixed string of several bytes, okay? Usually the 128 bytes is more than enough, because 128 bytes means it has... How many characters does it has? 128. Yeah, so each byte is one character. So it has 128 characters. Surely your name is not going to be more than 128 character. But if you use 128, you might actually run into a problem where the package is too large to be sent out. Sometimes it bottlenecks there. So for compatibility purposes, you can just do a 32 bytes fixed string. So you have the fixed string of this size, you have an integer, you have a float. So now you can just do So in order to serialize this properly, all you do is do a ref network serialize. No, where is it? Serializer, I think. Buffer serializer. No. Give me a moment. I think it's serializer dot add dot serialize value. Yes. Okay. Then you take in the ref to this. So then you just basically put all of this in as a serialized value. So what this is going to do is that it's going to serialize this data struct properly for you, so that you can directly use it as a network variable, and the correct data is going to get sent over properly. So you can use this to store things like player name. You can use this to store things like player ID, player score, right? And one thing that I forgot to mention, so this allows you to probably sync your names over, or if you have other data for your player, for example, if you're making other types of games that allow your player to select certain characters in your game, then you can also sync the character data that the player has selected with this struct, with this custom struct that has been implemented. Also, one thing that I failed to mention last week, and I don't think there is any value of mentioning it in a Pong game because there's only 2 players, right? Is that there's actually a different type of network, a sync network construct that you can define. It's called a network list. Okay, let me just remove this code because I don't need this anymore. It's called a network list. So I'm just gonna go into one of this. You can actually define a network list, and it takes in any kind of data, any kind of type that is an IEquatable. So let us go into the thing over here. Where's the network list? Oh, that is the RPC. Where is network list? Hey, Unity, fix your dock. Fix your dock, man. Okay, but essentially the network list must use T, which is a type of that is unmanaged, so it can only be a type of struct or one of the primitive types of C# that is not a string. Okay, a string is managed, so it must be unmanaged. So it must be a type of struct, or it's a type of string, or a primitive type that is not string. And it must also implement the system IEquatable interface, so that you can check for equality. Let's just go back here to show you how to implement the IEquatable. It's not IEquatable player data. So IEquatable takes in the same type as what you have, and then the T can be anything. So like implement this interface for IEquatable. And then basically all you need to do is to just override the equals method such that you just do a return this equals this, and just load player score equals other dot player score, and player name equals player dot other dot player name. So things like this, you can just implement the IEquatable directly like this. Okay, you can implement it like this, and then you can take this in your network list. Okay, like player data equals new. So this network list provides you with the different things. So it has this on list change that only has this one callback. That is actually pretty complicated to use. Can I just get myself to the fix your dock, man. The NGO network list. I want to get, yes, okay, this part of this documentation. So you can look up this documentation for more, but essentially inside of this network change, this callback, right? It takes in a change event and it takes in the player data as the thing. This is actually pretty disgusting to use, but essentially you actually need to do a switch case for change events dot is it type change event dot type. Yeah, so then you have the case where this is actually of this is of network list event type dot add. Yes, you have something like this, right? Was this not correct? Event type dot type. Event type does not. Okay, sorry. I think it's just very difficult to use this, but yes, on list change delegate takes in a network list event. This network list event has a bunch of stuff. Okay, it's not type, it's event type. No? Value index type. Get type. It is type. Yeah, it is type. And it returns me an event type. What is this event type? So this event type, which is part of the network list event, yes, okay. So there are these events here. There's add, clear, full, insert, remove, add value. This allows you to create a callback and what you want to do with data that gets sent over. For example, if your player data is updated halfway through, their score is updated, then you probably need to update this callback as well. Yeah, there's value changed, more importantly, but you can play around with this. This is actually pretty powerful, but it's just very difficult to work with because of how it is being implemented. So yeah, there's the network list that you can use. What else did I fail to mention? I think that is just about it for netcode for a game object, essentially. Yeah, it feels like. Okay, there's also this one last thing. There's also this one last thing called an RPC that I actually didn't mention because there is no reason why I need to mention it in a Pong game as well. So what is an RPC, right? An RPC is called a remote procedural call. Essentially, it allows you to send the network request without needing to send without it allows you to send network requests, but it doesn't use your normal like HTTP protocol. It uses it's basically its own protocol. It's called RPC, and it allows you to call methods of an object that is not in the same executable. It sounds pretty iffy, but basically what it means is that you can remotely call methods that exist on a different PC as long as they run the same version of the executable and the object exists. What you can do with this is do things like calling certain methods from your player if you actually need to, but it's a Pong game, I don't see any reason. But if you say you need to call things like your players take damage from a second player, and you want to call this from the second player use that, and you need to tell the second player how much damage it dealt, then you can just do a server RPC or a client RPC, or an RPC sent to something, so that you can do it. Actually, let me just show you a quick code on what you can do with this. So for say your add score, say when you're adding score, you actually don't want this score to be you actually want to call this add score from your client side as well. I don't know for whatever reason why you want to do this in a Pong game, but say you want to do this. So what you need to do is to first define this add score RPC and add this attribute to it, and then you can select where you want to send this remote procedural call to. In this case, most likely you're sending this to the owner, but you can send this to everything else. You can basically send this to everyone on the session as long as you know how to. But any specific user in the session, but you usually just send this to the server. So as you send this to the server, you call the add score RPC, and then you do like the int player ID. Right. And then all the logic here. I'm not gonna write all the logic here. Essentially, what this allows you to do is that you will be able to call this RPC method from your client code, and it's going to send a network request to the server that tells the server to invoke this particular function. So essentially, it gives you a lot of power to work with things, because now not only the server is able to manage over the methods, you can tell the client the client will be able to tell the server what methods it wants to invoke on the server's client. So this will be useful in any particular case where you want this communication to happen. But in a Pong game, there is no reason to do this, so that is why we didn't go through RPC. But when you're working with any other type of multiplayer game, you must use RPC, and in fact you will use a lot of RPC, so it is a good idea to take a look at what RPC does and how to do it. So this means that even if I'm on the player, okay, I'm just going to just very quickly demonstrate how this works, right? I'm just going to, for my score manager, no. Yeah, for my score manager, I have this RPC. I'm just gonna call this like print RPC. Okay. And then I'm just going to do something like this, right? I'm just going to do a debug.log, and I'm just gonna say player scored, player ID. Player ID scored. Okay. So now as I go into my player, it's like, where's the score manager referred to? It's by the score zone. Okay, so I don't want to call this in the score zone. I'm just going to call this in the player. So my player should now also have a... Okay, I'm just going to make this a singleton. Fuck this, right? Public static score manager instance. Let's make this a singleton, and then let's just make this a void start. Private void start. If instance equals null, instance equals this, else destroy this. Let's destroy game object. So I destroy myself. If I'm not the instance, I made this a singleton. So now I go into player movement, and I go into player movement, and let us just create a very simple like okay, let's not make it let's not make this. It's like RPC from player ID. Okay, so now if I go into player movement, I do a private I just do like a infinitely looping async task. It's like a infinite loop where I'm going to do a wait while true. Okay, await unit task dot wait for seconds random dot range. It's between 2 seconds to 5 seconds, for example. No, it's between 1 second to 3 seconds. Okay, and then I will be able to pass in then I will be able to do a score manager dot instance dot print RPC, and then it takes in a player ID. I can't get the player ID from the movement. I can in fact get the player ID from the movement. Singleton.client local client ID. This is a ulong, so I need to take this in as a ulong. So you can actually pass like different things inside of this. The only downside is that when it comes to RPC, usually you won't be able to return any values from this. If you try to return a value from this, like if I try to return an integer, this is going to warn me. Let's just return 0. If I do this, I think this is supposed to warn me, because RPC is not supposed to return a value. See? So RPC method must return a void. So if you're trying to like sort of like send data across each other, you must chain a lot of RPC into each other. But essentially this is what it does. So now if I go into the game, just very quickly, I just go into the game to show you what this does. Is that now as I press play, okay, I click on create rule. Then I have the room code here. Fuck. Can this engine actually be more stable? Okay, FFP66M. Join room. So what is actually going to happen is I forgot to call this infinite loop. So it's not being used. Yeah, okay. Okay, now this will work. So what you're going to see is going to happen is that the other players are actually able to send, it's actually able to call this method from the, even though it's not from even though you know it's across the network. So you'll see that it says RPC from 0, RPC from 1, RPC from 0, RPC from 1. So you can see that how this RPC can be called from the different client, even though you know it's not the client. But on the client side, it actually doesn't receive anything because I only send this procedural call. I only send this RPC to the server. So yeah, you can sort of make use of this you can sort of make use of this and achieve a lot of stuff with it, but essentially we don't need this for Pong because there's no like complicated communication that we need to do. So just clean up the rest of the code. So yeah, essentially this is all to this multiplayer workshop. Again, this is just a very basic setup, and but I think this serves as this serves its purpose to get you into learning multiplayer. It is pretty fun, but sometimes it leads to very complicated bugs that you need to fix because there is a lot of networking stuff that is happening, and sometimes it doesn't sync properly, sometimes it's synced, but it's just some random bugs that would happen because everything is networked. So yeah, if you're interested in continue doing it, I would recommend you to look up more on this by reading up the documentations. And finally, just to add on to this, Unity netcode for a game object is not the only multiplayer framework that you can use for Unity. Okay, it's not the only multiplayer framework that you can use for Unity. There are other options. Okay, there are other options that you can make use of. The most popular option outside of Unity, outside of Unity's netcode for a game object, actually this is probably still the most popular option, is fish networking. So fishnet is pretty much a freemium service. You can use it for free, but some of their features are locked behind premium. So the fishnet framework is more advanced than netcode for game objects. It gives you more power. It's also more optimized. It's faster in terms of performance. It has less latency, and it's much easier to make sure that everything is in sync. So if you're looking to make any kind of semi-competitive or competitive games with Unity, and you don't want to write your own netcode for it, Fishnet is a very good place to look into. It not only supports network interpolation, which we use for our network transform to interpolate the transforms, right? It also supports extrapolation, but the feature is locked behind premium, so you do need to pay. I think the lifelong subscription is only like $50. So if you really need it, then you can get it. Yeah, it supports extrapolation, which makes syncing data much more easier in terms of syncing transforms and a lot of the player inputs and stuff. It makes it more smoother. It's cleaner. So aside from Fishnet, there is also other options, like I think it's called Mirror. Yeah, you can also use Mirror, which is also a pretty popular option. There is also Photon. I think I can kind of look it up. It's like Mirror networking. So yeah, there's Mirror networking, which is open source, so this is free, but you can give donations as well. I've never used Mirror before, so I can't really tell you how it is. But apparently this is also pretty good, but it doesn't scale very well for large games. And there's also Photon networking for Unity, and it also works for Godot if I remember correctly. So Photon networking actually allows you to write server-side physics. This means if you make any kind of game that requires server-side authoritative physics, you can use Photon, but I think that requires you to pay. There is the Plus edition that allows for 100 concurrent users and stuff like that for just $95. Okay, that is not cheap. Okay, Yeah, these are some of the options that you can look into. Usually, you just use fishnet or netcode for game object if you're not doing any kind of very difficult stuff. But yeah, like I mentioned, this is not netcode for game objects is just not the only option when it comes to networking framework, but it is the easiest option to get started with for Unity, especially now that they actually made it half decent when you compare it to the other frameworks. And since you don't need to use the other frameworks and it follows whatever Unity has been using, and it has good engine integration with the rest of the tooling that Unity provides you with for multiplayer. So it is the preferred option to get started. I think it is still a pretty decent option on its own. It just doesn't support a lot of the advanced features. So yeah, I think that should wrap up for today's session. Any final questions? Any final questions? No questions.
think you could because I just want to see the book one for
Okay, sure. Which one?
let's see. From the menu, when you change the name from launch countdown for receipt to
Task, yes, because it's no longer a coroutine, it's a task. Just to follow the naming conventions.
So if you don't mind me looking.
Yes, starting. So